So class, today we are going to start this thermodynamics, and this is the important topic of class 11th and most conceptual topic of class 11th. Yes, of course it is full of numerical. So let's go through with this chapter, and in that first we should know that what do you mean by this thermodynamics. What we mean by this thermodynamics. Thermo means it's heat. Wherever this word comes, thermo, it means heat, and dynamic means movement, or we can say that the exchange. So where there is heat exchange, okay, wherever that heat exchange occurs, that branch, that things we will be studying in this chapter. That thing we will study in this part, thermodynamics. So actually in this chapter only this heat exchange only will not study. Along with this, lots of things are there that you will know, and it is quite new for you. We will learn all the different terminology over here. It's all enthalpy, gives free energy, entropy, so many things are there, so that we will learn one by one. Okay, so before that, let me start this definition. Let me start with this definition. The branch of chemistry in which we deal about the chemical reaction involving heat exchange. There will be the chemical reaction involving this heat exchange, that is known as thermodynamics. Okay, so see, in that we know that whenever we write this thermodynamics, or whenever we do the chemical reaction, what we write, we simply write the reactant is going to convert into the product, isn't it? This reactant is going to convert into the product. So actually what happens, there is the bond, already the bond is there. So in the reactant there is a bond, so this bond is going to break, then only it will form the new bond. So here the bond formation, yes, new bond formation occurs. Done with that. So since it has to this bond has to cleave, this bond has to break, so obviously the energy is required over here. Energy is required, yes, and here the new bond is forming, so the bond that energy is released over here. In general it is that like this, yes. And in that way only we check that if the net heat is released, that means this energy released is more than the energy required for cleavage of this bond, then obviously this reaction is called exothermic. Heat is releasing out, and if energy required is more than the energy released, that means whatever we have given the excess energy, extra energy, but the energy release is less, or we can say that during this bond formation the energy release is less, so that type of reaction is called endothermic. Don't worry about that, we will do it in details afterwards. Okay, so this is the things here. Now let me explain. This is the terminology. So there is few words that we have to start. That is, first is system. The first terminology is system. The system said that it is a part of universe about which we study, or about which we concern. Okay, so it is the universe, all that things is universe, and out of that the one part where you are going to, about which you are going to study, that a chemical reaction, a beaker, a chemical, whatever. Okay, so that is considered as a system for you, and the rest, all the parts around the system, that will be considered as what? Surrounding. Suppose that in this I have this beaker, and I have kept this chemical over here. Okay, so suppose that chemical is there, and I'm going to study about this chemical reaction over here. So this beaker is only system for me, and rest all the things whatever around it, like me, you, around, like air present around this, the room, the chemistry lab, wherever we are performing this experiment, that is what? That is surrounding for us. Clear? So that we will do afterwards. So let's start with the system. System I have explained, and there is three types of system. The one is called open system, another is closed system, third is isolated system. It's very simple thing. Open system, like where the matter and the energy both exchange, like exchange of both occurs. As for example, like just take an example, like you are studying and there is a glass of hot milk is kept over there in front of you on your table, and you are so busy in your study that you forgot to drink that. So when you like got this thing, okay, milk is kept over here, mama has kept it here, so I have to drink. So you will check that maybe half an hour, maybe 1 hour. So you see, you have observed that that milk becomes so cold, well, like thanda ho gaya, isn't it? And since it was open, so obviously some milk particle और उसके अंदर जो water था that gets evaporated, वो evaporate भी हुआ है. So that means there is the exchange of matter and energy, both are there. Got it? So such system is called open system. Another thing, mama came back and then she's have seen that the milk is like that only and वो ठंडा हो गया, तो she has taken it again, लेके गई वापस and then दोबारा उसको गर्म करके ले आए and then she covered that milk with the lid, suppose. So again you were so busy in study, भाई thermodynamics चल रहा है, you were so busy in doing the numericals and all that, you forget about the milk which is kept on your table. After half an hour, 1 hour, you have seen, so you realize that milk is kept over here, I have to drink. So when you have checked, that milk is again cold, ठंडा हो चुका है. Yes, so that means the heat transferred from the system was like milk जो था वो हमारे लिए system था, and that milk was having some heat, but surrounding was cooler, isn't it? So the heat transferred from the hotter region to colder region, isn't it? So that's why ये heat transfer हो गया milk से surrounding में. But since the milk was covered, so no milk molecule or whatever the things were there gets evaporated, wasn't able to evaporate. So that means there is only what? Only exchange of energy, no matter exchange is there. Yes, so only energy exchange. If only energy exchange, then it is called closed system. And the third time again mama came and she has seen that okay, फिर से milk वैसे रह गया. She was little like annoyed also, but since you were studying, तो मम्मा ने कुछ बोला नहीं, उठाया वापस से milk लेके गई गर्म करके. And now what she has done, she kept that milk in the isolated flask and on your table. Okay, so again as usual you are so busy in that study, so you were busy and you again forget to have the milk. But इस बार पी लेना, otherwise mama. Okay, so what happened? So like in that isolated flask it was there and you forgot afterwards. जब आधे घंटे के बाद 1 घंटे के बाद you realize that milk is kept over there. So what you have done, you have checked the milk and that time the milk was still hot. Yes, so what happened? Neither energy nor matter exchange takes place in that case, because since it was covered, so no matter exchange, and since it was isolated, so no energy was transferred. So where the neither matter or nor energy exchange takes place, that is called isolated system. Got it? So these are the 3 types of system. Example, it is written over here: a chemical kept in open beaker without lid, a chemical kept in beaker covered with a lid, and the third one is a chemical kept in the isolated beaker or the thermo flask. So this is the system. Got it? Now the surrounding. Other than in that universe, if you check that universe is made up of what? Universe is made up of system plus surrounding. Yes. So let me write complete surrounding. So we have done that system, we have done. Now the surrounding. Yes, so surrounding is what? Surrounding is everything in the universe. Everything in the universe exclude this system. System को छोड़कर जो भी हमारे आसपास है, everything, that is called surrounding. Okay, so I hope it is clear. Yes, now a new word came, that is called boundary. What is this boundary? So obviously everyone knows this boundary, but here we will learn few other types of boundary. So boundary, what it is? The line which separates the system and the surrounding. System और surrounding को जो separate करे, that is called boundary. Yes. So it can be of like 2 types. It can be fixed or movable. As for example, in a glass you kept the water and you just left it for some time. So there is a fixed boundary. You can see that the glass wall and something like that. It is a fixed. Now in that glass you are filling water and just under the tap. So what will happen? You'll see that there is a movable boundary, isn't it? The boundary is moving, like पानी उस पे गिर रहा है, so there is a movement. So that boundary, the upper surface, is not fixed. It is moving. So that is called movable boundary. Yes. Next type is real and imaginary. Real, that means which is fixed, we can see, and another is imaginary, which we have to assume. As for example, I have taken this example and I said this, there is a beaker, in this the chemical is kept over here. Okay, so this chemical is system for us. For this is the real boundary. Here it is real boundary. Yes, but in this above, this here it is air. Yes, so air is also surrounding, but can you see this? There is a boundary between the air and the system, that chemical. You can't see. So that is called imaginary boundary. Clear, bachche? So this is called imaginary boundary. And the third type of boundary is adiabatic boundary and diathermic boundary. Adiabatic boundary and diathermic boundary. We will learn about this thing आगे हम पढ़ेंगे, but still I am giving you a little knowledge over here. Adiabatic, that means no heat transfer. Okay, like isolated, we were doing insulated or isolated. There was no heat transfer. So that means neither the heat will transfer from the system, neither the heat will transfer from system to surrounding nor surrounding to system. Okay, so that is called adiabatic. That means there will be no heat exchange. Okay, and diathermic, where the heat can be exchanged, like we have kept in this case or this case, that it was going to be cooler. Yes, so that means the heat was transferring from system to surrounding. May transfer from surrounding to system also, it depends. So that is called diathermic. We'll do in detail. Okay, so this is for boundary. Now we will know about the thermodynamic properties. What are these thermodynamic properties? See, the first lecture will be just a basic knowledge about the thermodynamics, and then we will start the main thing. Okay, so these are the terms and that you are supposed to learn. You should be very clear with these terms, because so many MCQs can be asked from this topic. Okay, so out of this thermodynamic properties, it is also called as variable. It is also called these are the things. Okay, so two type of properties we have. One is called extensive property and intensive property. See, it's quite confusing. But if you will make a trick, or if you will learn it with a trick, so it will be easier for you. Extensive, that means which will depend. Okay, X means depend. We will relate like this. X depends. Okay, so extensive properties, such properties which depends upon the size of the system or amount of the matter. Okay, amount or size of the system, if it depends, then it will be called extensive properties. Like we can say mass. Yes, there is suppose that some mass will be there for this pen. If I will break it, so will that mass will be same? No. Or will that mass be same? No. So that's why, that means it is depending upon the size, isn't it? So example, mass, volume, length, moles, heat capacity. Okay, gives free energy. And one more thing I told you, wherever this energy comes, if any word with the energy comes, you can blindly say it is a extensive properties. Okay, and enthalpy is also a term for form of energy. Yes, energy, we can say entropy. So these all things are extensive. Okay, intensive properties are such properties which do not depend upon the size, or the amount of the system. And here it is depending. Yes, intensive, do not. Extensive, yes, depends. Okay, example, density. Up, if you take 1 glass of water or you take half glass of water, the density of water will remain same, isn't it? EMF, that you will learn afterwards. EMF, that in the physics you know that, electromotive force. Dielectric constant, it's a constant for every material. There is a constant, and the fixed constant, it is actually depends upon the matter. हर matter का एक अलग constant होता है. So that is specific heat capacity. There is a confusion. See, heat capacity, if it, I'm saying, so heat capacity is an extensive property, but if it is specific, then it will be intensive. Clear? Okay, so temperature, refractive index, it all depends upon the mass of the substance. Boiling point, if I will say, boiling point, it will be what? Do not depend. Yes, so here will also it will come. Boiling point is also an intensive property. Viscosity, refractive index, temperature, चाहे आप 1 gram ka lo ya 10 gram ka lo, temperature is not going to change, isn't it? Boiling point is not going to change. So all these properties will come under intensive. Lots of properties are there, so we have to relate with the mass or the size of the system. Okay, one important thing I'm going to tell you, this is the ratio of two extensive properties. The ratio of two extensive property, if we take, then it will be an intensive properties. As for example, just take it at this specific heat capacity. You don't know, I don't know whether you have done in physics or not, but this specific heat capacity formula is Q upon M delta T. Yes, so Q is here extensive property, M is also extensive property, so ratio of extensive property is intensive property, so that's why it is intensive. Yes, similarly you can use for that viscosity, that is okay. Another example you can take, just like here I have used this EMF. So in EMF, you know that EMF formula, if physics you have done, that is the work done per unit charge. Yes, so work done is a form of energy, so this is what? Extensive. Yes, and charge is also extensive, because it depends upon mass. Yes, isn't it? Number of electrons kitne honge, uske according charge hoga, so number of electrons, mass, it is having some mass, so that's why this is also extensive. So this will be intensive since it is the ratio. Okay, another formula also you can take. So this is the things now. So this point you have to keep in your mind. Okay, now let's start with the process. Processes, what are that processes? So here, on the basis of constant condition, that means something or one thing or other thing we have to keep constant. So depending upon the constant condition, the process are of 4 types. One is called isothermal, another is isobaric, third is isochoric, and fourth is adiabatic. Iso means same, we know that. Isothermal, temperature. So where the temperature is same, that means delta T will be 0. Yes, got it? Isobar, iso means same, bar means pressure. So where the pressure will be same, that means delta P is 0. Isochor, iso means same and choric means volume, where the change in volume is 0. Yes, and adiabatic, right now also I have explained in previous sheet here, that heat transfer, there will be no heat transfer. So the Q is 0, delta Q or Q you can say, that means koi heat transfer hi nahi ho raha. Yes, so either you can say Q or delta Q, it's okay, dono चीज same here, that will be 0. समझ में आई बात? So this is very important point, because on this things we have to solve the numericals, so that thing it should be clear in your mind. Okay, so now if we learn something about this process in little detail, so what it will be. So see, we will learn in this states of matter also. If it is in this case, delta T is equal to 0, and we know that there is a formula PV is equal to nRT, isn't it? So this is 0. This is, that means T is going to be constant. This is delta T, isn't it? And that means this T is going to be constant. R, universal gas constant, that will be constant, and amount of substantial amount of gas which we have taken, that is also constant. Okay, so what will happen? This is, we can say that P is equal to, this is whole constant upon V, can I say? Yes, that means P is inversely proportional to volume, isn't it? So if we plot a graph for this between pressure and volume, we get a graph like this. It is like this. Okay, we'll get, because inversely proportional, it always comes in a curve. Yes, so this will come like this. Okay, and this is a graph of which is depicting the Charles law. Okay, Charles law, that it is in the states of matter. Okay, now next thing, if we do about this isobaric, that means pressure remains constant. Again the same formula used, PV is equal to nRT. This time what it is, R is constant, N is constant, and P is constant, isn't it? So can I write that V is equal to nR upon PT? That means V is equal to constant upon P, constant upon into T, isn't it? This whole is constant, isn't it? So that means V is directly proportional to T. So if we plot a graph between volume and temperature, we will get as a, because it is directly, so inclined way we will get. Okay, and this is depicting the Boyle's law. These are the laws in which we have to do in the states of matter, and that is same like that. Okay, so here you should know only that law, what it is. I will tell you, I will explain it in states of matter, don't worry about that. Okay, now the next thing, again the same formula only, PV is equal to nRT, and here what is the volume remains constant. So this is constant, this is constant, this is constant. So what you will get, we will get this P is equal to constant nr upon V, constant into T. Can we write? That means P is directly proportional to T. Yes. So if we plot a graph between the pressure and temperature, that in that case also we will get a straight line this, and this is depicting the third law, that is Gay-Lussac law. Gay-Lussac's law. Okay, that we will do it in detail. Done. And see, if we do about the adiabatic, that means Q, heat transfer is 0. Heat transfer remains constant. There is no heat transfer. That means it is quite clear that the boundary is what? Isolated, isn't it? Isolated or insulated, we can say. Yes. So that is, in that case, we can say that there is no heat transfer between system and surrounding. Okay. If in this case also, if we plot a graph between P and V, we get a graph like this. So that is like not important. This is not so important. This graph won't be asked, but we get the graph like this. Got it? So this is all about the processes. Now next topic is our state function and path variable, that we will do. Okay. About the next topic, that is state function and the path variable, what it is, we will do in our next class. Okay, so till then, thank you class.